Last episode, Weaviate gave us a managed vector database we could query over the network, search as a service. But search isn't the goal, it's the setup. The real question is, how do you take what you retrieved and turn it into an answer that's actually grounded in your documents instead of the model's imagination? Here's the problem nobody warns you about. A language model answers from memory everything it saw in training, frozen at a cutoff date, with no idea what's in your wiki, your tickets, or last week's incident report. So you ask about your own system and it answers fluently and wrong. Confident hallucination is the default failure mode, and it's the one that gets you paged. The fix isn't a bigger model, it's an open book exam. Before the model writes a single word, you run a search over your documents and hand it the relevant pages. That's the whole idea behind Retrieval-Augmented Generation. Retrieve first, then generate, with the evidence sitting right there in the prompt. To search documents, you first have to cut them down to size. You chunk, split each document into small passages a few sentences long, then embed every chunk into a vector, the way we did back in the embeddings episodes. A question becomes a vector too, and relevant just means nearest neighbor. FAISS already does that lookup in microseconds. And here's the part that turns trust on. Every chunk carries the ID of the document it came from. So when the model answers, it can point at the exact source, chunk 7 from the deployment doc, and you can check it. Retrieval, you can verify, is the difference between a demo and a system you'd actually ship. Let me show you the smallest honest RAG you can build. We've got 4 tiny documents. We chunk and embed them with a seeded offline encoder. We index the chunks in FAISS, and then we ask one question. Retrieval is completely real. FAISS does the work. The only thing I'm faking is the final language model call, and I'll mock it deterministically, so the output is the same every run. First, we build the corpus and chunk it. Each document is split on sentences into short passages. And crucially, we keep a source ID on every chunk. That's the breadcrumb that lets us cite later. We embed each chunk with a hashed bag of words encoder, seeded to 42, so the vectors are real and reproducible without downloading a model. Then we index. We L2 normalize every chunk vector and push them into a FAISS index flat IP, so an inner product search is exactly cozy in similarity. This is the same FAISS API from the indexing episode. Index.add-once, index.search per query, no surprises. Now the query. We embed the question, how do I roll back a deployment? The same way, normalize it, and ask FAISS for the top 3 chunks. Then we build the augmented prompt, literally the retrieved passages stitched above the question, and pass it to mock generate, which deterministically quotes the single best chunk. That's the one mocked line, and I'm telling you it's mocked. Run it. FAISS returned the top chunk as it rollback doc Zoro with a cosine score around 0.56, clearly ahead of the next 2. The generated answer quotes that passage word for word, and the cited source comes back as rollback doc. The assert at the bottom checks the cited chunk AD equals the true source ID for the question, and it passes. Look at the figure and the terminal together. The bar chart's tallest bar is the same chunk FAISS ranked first, the same score printed in stout, and the same source the answer cites. Retrieval, ranking, and citation all point at one chunk. That's grounding, you can see. RAG turns the model knows into the model looked it up and showed its work. Next episode, we go from a flat list of chunks to a web of connected facts, from RAG to graph RAG,